want you to picture a wheel, a big wooden wheel, maybe 4 feet across, with little hammers attached to the rim on hinged arms. You give it a push. As the wheel turns, the hammers on one side swing outward, away from the center. The hammers on the other side fold inward close to the axle. So the descending side is always heavier, always pulling down harder. The wheel should just keep turning, right? It should spin forever. And if it spins forever, you can hook it up to anything. A grain mill, a water pump, a generator, free energy forever from nothing but clever geometry and the pull of the earth. That idea is completely wrong. And it took humanity about 800 years to understand why. Not because people were stupid, they were brilliant. Some of the finest minds that ever lived stared at machines like this and could not find the flaw. The flaw is not where you think it is. It is not friction. It is not air resistance. It is not bad engineering. The flaw is woven into the fabric of the universe itself. And once you see it, you will never look at energy the same way again. Let me take you through this properly, because the story of perpetual motion is really the story of how we learned what energy is. And that is one of the greatest stories in all of physics. Start in the 12th century, India. A mathematician named Bhaskara draws a wheel with curved hollow spokes filled with mercury. As the wheel rotates, the mercury flows from one end of each spoke to the other. The spokes going up carry the mercury close to the center. The spokes going down carry it far from the center. So gravity pulls harder on the descending side. The wheel, Bhaskara says, will never stop. Now, Bhaskara was no fool. He was one of the great mathematicians of the medieval world. He understood geometry, algebra, early calculus, and his logic sounds airtight. If one side is always heavier, how can the wheel not turn? Jump forward 100 years. France. An architect named Villard de Honor sketches his own version in his notebook. Same principle. Weights on hinged arms. The descending side always carries the load farther from the axle. The ascending side tucks the weights in close. Villard drew it with complete confidence. He was sure it worked, but already there is a subtle problem that neither Bhaskara nor Villard noticed. Count the weights on the side where they swing outward. Yes, each weight is farther from the center, but there are fewer of them on that side at any given moment. On the side where they tuck inward, the weights are closer to the center, but there are more of them. The torques balance. They always balance, no matter how clever you make the geometry. The gravitational pull on one side is exactly compensated by the distribution of mass on the other. Always it is as if gravity has already done the bookkeeping before you even built the machine, but people did not see that. For centuries they kept trying and the designs got more elaborate. Robert Flood, an English physician, proposed a closed-cycle water mill in 1618. Water falls and turns a wheel which powers a pump which lifts the water back up round and round forever. Robert Boyle designed a flask where liquid would supposedly flow uphill by capillary action and then pour back down. Johann Boni proposed a fluid machine that would run on buoyancy. Each design was more ingenious than the last. Each one failed, and then came Bessler. Johann Bessler, who called himself Orpheus because he was the sort of person who encrypts his own name and thinks it makes him sound important. And Bessler is the most interesting case of all, because his machine actually appeared to work. In 1712, he built his first wheel in the town of Gur, about 6 1/2 ft across. It could lift small weights. He demonstrated it publicly, and observers could find no obvious source of power. Then he built a bigger one near Leipzig, 9 ft in diameter. This one spun at 50 revolutions per minute and could raise a 40 lb weight. Gottfried Leibniz himself came to watch. Leibniz, one of the inventors of calculus, arguably the greatest universal genius of the 18th century, watched the wheel spin and wrote letters saying he believed it was real. Then Bessler built his masterpiece at Wittgenstein Castle under the patronage of Prince Karl of Hesse-Kassel. He constructed a wheel 12 ft in diameter. Williams Graves, professor of mathematics and astronomy at Leiden University, examined it. He checked the axle. He looked for hidden belts and cords. He could find nothing. The wheel was sealed inside a room. The doors locked, the windows sealed. 2 weeks later, they opened the room. The wheel was still spinning. They sealed it again. 54 days later, still spinning. 26 revolutions per minute. Think about what this looked like to the people in that room. A wheel isolated from all apparent energy sources, spinning by itself for nearly 2 months. Some of the best scientific minds of the age standing around it, unable to find the trick. As Graves wrote to Isaac Newton, he said he could not explain what he had seen. Now here's the part about Bessler that tells you everything. In 1727, his maid ran away from his household and testified under oath that she, along with Bessler's wife and his brother, had been taking turns cranking the wheel from an adjoining room through a hidden mechanism in the wall. The whole thing was a fraud. But the fact that it fooled so many intelligent people tells you something important. It tells you that the idea of perpetual motion is so seductive, so natural, that even trained scientists will overlook evidence if the demonstration is compelling enough. They wanted it to be true, and when you want something to be true, you do not look as carefully at the axle. So let us ask the real question, not why Bessler's wheel did not work, because the answer to that is boring. He was cheating. The real question is, why can no wheel like this ever work? What is the actual physics? And this is where it gets genuinely deep. Start with the most obvious objection. People say, well, friction, if you could eliminate all friction, then a spinning wheel would never stop. And that is true in a very limited sense. In a perfect vacuum with frictionless bearings, a wheel that is already spinning would continue to spin indefinitely. That is just Newton's first law. An object in motion stays in motion unless acted on by an external force. But notice what that wheel is doing. It is spinning. That is all. It is not lifting a weight. It is not grinding grain. It is not generating electricity. The moment you attach it to something and try to extract work, you need to apply a force which slows the wheel down, which means you need to put energy back in. And where does that energy come from? This is where the first law of thermodynamics enters the story. Energy cannot be created or destroyed, only transformed. If your wheel is doing work, the energy for that work must come from somewhere. If it comes from the kinetic energy of the spinning wheel, the wheel slows down. If it comes from gravity, then the weights must fall and someone has to lift them back up. There is no free lunch. There never was. A machine that claims to produce work from nothing, that outputs more energy than it receives, is called a perpetual motion machine of the first kind. And the first law forbids it absolutely. The energy books must balance always. But now comes the subtle part, the sneaky part. Suppose I do not try to create energy. Suppose I only try to recycle it perfectly. My wheel turns and the energy it uses to lift the weights on one side is exactly the energy it gains from the weights falling on the other side. No energy created, no energy destroyed, just perfectly lossless recycling. That sounds like it should work. And the first law by itself does not forbid it. The first law only says the books must balance. It does not say anything about which direction the process goes. But the second law does. The second law of thermodynamics is the law that kills perpetual motion for good. And it is more fundamental, more far-reaching, and more philosophically disturbing than the first law. Let me explain it carefully. Imagine you drop a ball. It falls, bounces, and eventually comes to rest. Where did the energy go? It did not disappear. The first law is not violated. The kinetic energy of the ball was converted into heat, into random molecular vibrations in the ball and the floor. Every single joule is accounted for. But can you gather up all that scattered thermal energy and use it to make the ball bounce back up to its original height? In principle, every molecule in the floor and the ball received a tiny bit of kinetic energy from the impact. Could you somehow collect all those tiny motions and redirect them upward? The answer is no. Not because it violates energy conservation. It does not. The problem is that gathering diffuse thermal energy and concentrating it into the organized kinetic energy of a ball moving upward requires you to decrease the entropy of the system. And the second law says you cannot decrease the total entropy of an isolated system. Entropy, which is a measure of how spread out, how disordered, how statistically mixed up a system is, can only increase or stay the same. It cannot decrease on its own. This is not an engineering problem. It is not about needing better insulation or smoother surfaces. It is a mathematical fact about the way probability works when you have an enormous number of particles. The number of ways energy can be spread out among trillions of molecules is so incomprehensibly larger than the number of ways it can be concentrated in one place that spontaneous concentration is, for all practical purposes, impossible. Think of it this way. Imagine you have a room and all the air molecules are on one side. That is a very organized arrangement, very low entropy. Now you open a divider. What happens? The air spreads out to fill the whole room. Obviously, everyone knows this. But here's the deep question. Why does it never go back? Why do the molecules never spontaneously rush back to one side and leave the other side empty? They could. There is no law of motion preventing it. Every single collision between molecules is reversible. If you filmed one molecule bouncing off another and played it backward, you could not tell which direction was forward. The laws governing the collisions are perfectly symmetric in time. So why does the gas never unmix itself? The answer is probability. Pure, brutal, overwhelming probability. There are fantastically more ways for the molecules to be spread out than there are ways for them to be bunched on one side. The number of spread out arrangements is so staggeringly larger than the number of bunched up arrangements that the chance of spontaneous unmixing is not just small. It is effectively zero. Not zero by decree, zero by mathematics. 10 of 10 to the ends of 23 kinds of effectively zero. That is a number with more digits than there are atoms in the observable universe. And this is what kills perpetual motion, not some engineering limitation, not friction, though friction makes things worse. What kills it is the sheer mathematical fact that energy, once spread out, does not spontaneously concentrate itself again. You cannot unscramble the egg. You cannot unring the bell. You cannot take a room full of lukewarm air and use it to boil a kettle without putting in more energy from somewhere else. This was understood slowly, painfully over about 2 centuries. Let me walk you through the key moments because the story of how we figured this out is fascinating. It starts with a young French engineer named Sadi Carnot. 1824, France is an industrial nation running on steam engines. And Carnot wants to understand how efficient a steam engine can possibly be. Not a specific engine, the best conceivable engine, the theoretical limit. And what Carnot discovers is stunning. He shows that no engine, no matter how perfectly built, can convert all the heat it receives into useful work. Some heat must always be dumped into a cooler reservoir. Always the efficiency of the engine depends only on the temperature difference between the hot source and the cold sink. Not on the material the engine is made of, not on whether it uses steam or gas or liquid metal, just the temperatures. This meant there was a fundamental limit to how much work you could extract from heat. Nature itself imposed a tax on every conversion, not because of bad design, because of the way the universe works. A few decades later, Rudolf Clausius in Germany and Lord Kelvin in Britain took Carnot's insight and turned it into a precise law. They formalized the concept of entropy and stated the second law of thermodynamics clearly. In any spontaneous process, the total entropy of the universe increases. That law has never been violated, not once, not in any experiment anywhere ever. People have tried. Believe me, they have tried. Now, let me tell you about a beautiful attempt, one of my favorites. It involves a thought experiment that troubled physicists for nearly 100 years. Maxwell's demon. James Clerk Maxwell in 1867 imagines a tiny intelligent being sitting by a trapdoor between 2 chambers of gas. Both chambers are at the same temperature. The little demon watches the molecules. When he sees a fast one heading toward the right chamber, he opens the door and lets it through. When he sees a slow one heading left, he opens the door the other way. After a while, all the fast molecules are on one side and all the slow molecules are on the other. One chamber gets hot, the other gets cold. A temperature difference created from nothing which you can use to run a heat engine. Free energy from sorting. Maxwell posed this as a genuine puzzle, and it took nearly 100 years to fully resolve. The answer, which was worked out by Leo Szilard, Leon Brillouin, and finally Ralph Landau in 1961, is this: the demon has to observe the molecules. Observation requires information. Storing information requires physical resources. And erasing information, which the demon must eventually do because his memory is finite, generates heat. The heat generated by the demon's information processing is at least as much as the energy gained from the sorting. The books balance. The second law survives. That is remarkable. It means the laws of thermodynamics are connected to the laws of information. Entropy and information are 2 faces of the same coin. The universe charges you for the act of knowing something, and it collects the bill in entropy. Let me tell you about another attempt. One I spent quite a bit of time thinking about: a ratchet and paw. You know what a ratchet is? A gear with angled teeth and a little lever, the paw, that clicks against the teeth and lets the gear turn one way but not the other. Imagine a tiny paddle wheel sitting in a gas. The gas molecules bounce around randomly, hitting the paddles from all sides. Sometimes a molecule hits hard enough to push the paddle and click the ratchet forward. One tooth, the ratchet prevents backward motion, so over time the ratchet should click, click, click in one direction. You could hang a tiny weight from the axle and lift it. Free work from random thermal motion at a single temperature. I analyzed this very carefully, and the answer is beautiful in how disappointing it is. It does not work. The pole, the little lever that holds the ratchet in place, is also a physical object. It is also at the same temperature as everything else, which means the pole itself is jiggling from thermal energy. Sometimes through pure random motion, the pole bounces up high enough for the ratchet to slip backward one tooth. When you do the calculation, the probability of forward clicks versus backward slips is exactly equal. The ratchet goes nowhere. It jiggles back and forth with perfect balance. No net motion, no work. The only way to make it work is if the gas on the paddle side is at a different temperature than the gas on the ratchet side. Then you get net motion, but then you are running a heat engine, which is perfectly legal. You are extracting work from a temperature difference, paying the entropy tax, and dumping waste heat into the cooler reservoir. There is no magic. A hot ratchet, by the way, does something wonderfully ironic. If the ratchet side is hotter than the paddle side, the ratchet runs backward. The pole bounces so violently from the heat that the whole mechanism reverses direction. The machine designed to go one way goes the opposite way. Nature has a cruel sense of humor about these things. So what does all of this tell us? Let me gather it together. Perpetual motion is impossible because of two fundamental facts about the universe. First, energy cannot be created. Whatever energy goes into a machine must come from somewhere, and whatever comes out cannot exceed what went in. Second, energy degrades. Every time energy changes form, some of it becomes heat, and that heat spreads out and becomes unavailable for doing work. Between these two laws, there is no loophole, no clever design, no overlooked corner. The laws of thermodynamics are not like traffic laws, which clever people find ways around. They are more like the geometry of space. They describe what the universe is, not what it should be, and no amount of ingenuity can change the shape of reality. But I want to end with something that I think is even more interesting than the impossibility itself, because the second law of thermodynamics is connected to something you might not expect. It is connected to time. Think about what the second law really says. It says that entropy increases. Things go from ordered to disordered. That gives time a direction. The past is when things were more ordered. The future is when things will be more disordered. Every physical process you have ever seen, every experience you have ever had that tells you which direction time is moving is ultimately rooted in the second law. An egg falls off the table and splatters on the floor. You know which direction time is going because the egg was whole in the past and broken in the future. But the laws of motion, the equations that govern every single molecule in that egg are perfectly reversible. They do not know the difference between forward and backward. The directionality of time comes entirely from the overwhelming statistical tendency of things to become more disordered. So when someone asks, why is perpetual motion impossible? The deepest answer is this: because time moves forward, because the universe has a direction, because every moment in every corner of reality, the cosmic ledger of disorder is ticking upward. And no machine, no matter how ingenious, can make it tick the other way. That is not a limitation of human engineering. That is a feature of reality itself. The impossibility of perpetual motion is not a failure. It is a clue. It tells us that the universe is not a circle. It is an arrow. It goes somewhere. And every attempt to build a machine that loops back on itself, that recycles perfectly, that runs forever for free, is really an attempt to bend that arrow into a circle. And nature will not allow it. Not because nature is cruel, because nature is honest. The universe does not owe us free energy, but it gives us something better. It gives us rules, consistent rules, rules that work the same way everywhere. And those rules, if you learn them well enough, let you do extraordinary things. The sun pours a staggering amount of energy onto this planet every single day. Atoms hold tremendous energy in their nuclei. The wind blows, rivers flow, tides rise and fall. There is no shortage of energy in this world. The challenge has never been finding energy. The challenge has always been converting it wisely, honestly, within the rules. And the people who do that, who learn the laws and work within them, who accept the entropy tax and design around it, those people build engines and turbines and solar cells that actually function. They change the world, not by cheating physics, by understanding it. So here is what I want you to think about. Forget wheels and ratchets for a moment. What if the laws of thermodynamics could be violated? What if perpetual motion were possible? What would that universe look like? I will give you a hint. It would be a universe without time, without memory, without any distinction between past and future, a universe where eggs unbreak and smoke gathers and the dead rise. Would you want to live there? Think about that carefully and write to tell me your